Right. Yeah. Yeah. I was going to give a couple more minutes.
Well, thanks for getting that data, Baron.
Right.
I'd say maybe even more, thanks for getting the spindles.
Yeah, it'll be interesting to see the results from all the students.
Yeah,
Uh,
Whoops. As you can imagine, it's better for us as a company if more people know about spindle metrology, even if it doesn't mean they buy something from us. The fact that they know about spindle metrology is a good idea. So,
yeah, no, in general, I think the process that you do in spindle metrology applies to about everything in life anyway.
even my lawnmower.
Yeah, even cutting a piece of wood in the garage, right? If you want to do it, use it all is a square.
Right.
That is no square, right?
No, when I bring my lawnmower blade into work every few years and I sharpen it and then I try to make sure it's balanced.
Yeah.
And the technology that I have for balancing the lawnmower blade is probably like 2 centuries ago, where you just put it on a pivot and then you look and see if it's leaning one way or the other.
Yeah, but that works for one way, one direction.
It's better than doing nothing, presumably.
all right.
Exactly.
I'm going to do a roll call. So we just want to make sure at least one representative from each school is present. I see Nicholas from Auburn, uh, Alim from Huddersfield. I saw Dallin from Navajo. Uh, who's here from Austin?
Hi, I'm here from Austin.
Nice. Okay. Thank you. Do we have anyone from Northwestern plus Wisconsin team?
Yeah, I'm from Northwestern.
Nice. Did I miss one more team?
Maybe did, did I hear somebody from Huddersville?
Yeah,
Oh
yeah,
no.
yeah. Yeah,
Yeah.
yeah. Alim's here.
Okay,
Yeah, I
good.
think yeah, we can get started. Let me go ahead and share the PowerPoint. Yeah, you see my big screen. Do you?
Yep.
Okay, great. All right, so this is the agenda for today. First, we'll go through a short history of the student challenges we had in the past, and then we'll introduce you to this year's student challenge and the hardware involved, and we'll open up the floor for Q&A. You can stop me at any time. This is more of a discussion, not a presentation, right? So what is the vision behind the student challenge? So we want to provide a hands-on design and build environment, demonstrating precision engineering principles in a engaging environment. So when you're at the conference, make sure not to just dig too deep into your project, but also make conversation with fellow students and anybody with gray hair that's present around. So they are most probably an expert in precision engineering. Another main point is this challenge gives access to companies to a great pool of talents in precision engineering. Talking about companies, this is the list of our sponsors this year. So yeah, make conversations. I bagged a internship by participating in the Student Challenge in 2018, and then now I currently work at NIST, which was also a sponsor in the past. A short history. So this all started in 2014 in Boston. So this was a improv challenge where a Motus mechanical flexure block kit was brought, and teams of students who registered did these three challenges of design, controls, and metrology. Next year, we got a little more organized. We announced this tuning for penny scaler challenge for that students designed and built XY scanners. So they first submitted a design to us and then told us the number of make blocks and flexures they use. So we brought it there and they built their design at the conference. Next year is a really fun challenge. They wrote the PE logo using this laser pointer on the wall. Using this design shows two cross strip flexures doing the pitch and yaw motions to write this PE. In Charlotte, this was the first year I participated. Todd Nost, who's also in the committee here, he also participated in the challenge. We had two different teams from Charlotte. This year, they're not even participating. It's a shame. So the students built the flexure-based mechanism, which was kept on this shaker table, and we attached a laser pointer on top of the mechanism, and we all watched this white board here. So the idea is when they don't close the loop, the laser dot will be going all around the place. They close the control loop to keep the laser dot from not moving. So that was the challenge. In 2018, students measured thickness of glass plate down to 100 micrometers. For that, they used this homebrew confocal probe. And when the focus point of the probe meets the top and bottom faces of the glass plate, which is scanned using the vertical stage that the teams design, they get two peaks, which they relate to the distance by using the line precision capacitance probe. So that was the challenge that year. Interestingly, three people from this group who participated as a student back in the days now are actually part of the committee running the student challenge. You could be one of them in the future. In Pittsburgh, we built kibble balances. So the NIST made these masses made of stainless steel, which all these six teams measured, and they were assessed based on the thing is, with the regular weighing scales, you can calibrate the mass using reference mass, but with the kibble balance technique, you realize the mass straight away using the physics. So that was the challenge that year. And fun fact, I work on a tabletop kibble balance right now at NIST after 5 years since participating in this challenge. It really gave me a good head start.
That was the year they redefined the kilogram as well.
That's true.
Mhm.
Yeah, now it's related to Planck's constant, not a artifact sitting in France. 2020, we all know what happened. We had pandemic. We were really excited to give students this two-axis air bearing stages custom built by New Way Bearings to make diffraction gratings using a diamond tip. But we had to turn a couple of notches down and ask the teams to design a force control mechanism using this dummy tool. The idea is to make a diffraction grating. It is ideal to control the force that the tool applies on your specimen. Next year, the teams brought their design to Minneapolis and attached it to the XY stage. Some of the teams also participated as a virtual team because the travel bans were still in place. So this is the gratings manufactured by one of the teams. And Zeiss helped us to measure these gratings at the conference itself. So I was really grateful of them. 2 years ago, we measured Alvarez freeform mirror, which Corning helped us manufacture, which has a 50 micrometer peak to valley surface deviation. For that, the teams used the optical pickup unit you find in DVD players. So this shows a grid type scan one of the teams implemented to get a really fine sampling. And this shows a pretty fun implementation of calibrating the motion of this optical pickup unit in z-axis and related to the measurement given by the capacitance probe. They basically tilted the XY stage vertically and did this measurement. Last year, teams position controlled the air bearing stage using the self-built interferometer. Here are the optics involved, and they were position controlling with respect to the corner cube attached to the air bearing stage. To assess their performance, we put a commercial interferometer, which was measuring the corner cube attached right behind it. So they had to follow this three-step ramp profile, and teams were able to do this with a nanometer level of accuracy. So this brings us to this year's challenge, where we'll be measuring the roundness of this stainless sphere ball. For that, Professional Instruments graciously donated the air bearing spindles we'll be using. which will be spinning the ball, and Lion Precision has donated 50 micrometer range, sub-nanometer resolution capacitance probes, which will be measuring the radial motion of this ball. From that, we implement the Donaldson ball reversal principle to obtain the roundness of the ball. The spindle is driven by the DC motor with the belt attached, and you have this voltage controller to change the speed at which you can rotate the spindle. The 16-bit ADC measures the capacitance probe because National Instruments MyRIO can only do 12-bit resolution. And here's the dial indicator on a adjustable arm that you can use to center the ball coarsely before you use the capacitance probe because the capacitance probe only has a 50 micrometer range. We also have given you this three-stage air filter, which filters air, oil, and then it dries the air with the desiccant in the third stage. And there's a 512 count rotary encoder attached in the bottom of the spindle. Both the ADC and the rotary encoder is read by the MyRIO. So this is a measurement we got out of our prototype. So this is the first measurement, about 8 rotations of the spindle at 0-degree orientation, and then we flip the ball 180 degrees, and also the probe 180 degrees, and did the second measurement. We fit a sign to both these measurements and remove the sign. And this shows the errors in both the spindle and the ball. And we implement the Donaldson equations to separate them. The blue curve shows the ball error, and the orange curve shows the spindle error. As you can see, the spindle error is 10 times better than the ball error. So this is just to give you an idea of what you can expect from the system. What you're receiving, here's the full bill of materials. Lewis came up with a nice idea of attaching the filters straight onto the box so that you don't have to attach it to a separate stand or anything. You simply open it and connect the the tube that goes to the spindle. Yeah, here's where the spindle is hidden. This is the rotary encoder I was mentioning about, and the dial indicator to core center the ball. The air filter. So a few things we need to keep in mind is make sure you drain the filter once at least every day. And then also keep an eye on this desiccant. It will turn from blue to pink when it starts to absorb more moisture. So you need to replace that. The kit comes with extra desiccants, but from my experience, I found that the desiccants, it turns pink real quickly. That came as part of the kit. So if you want to purchase a different kind, you can use this Amazon link. It's less than 20 bucks, and this seemed to work better than the one that comes as part of the kit. And we'll be happy to reimburse you. I'll just Venmo you if you could tell me how much you spent on it. So yeah, the MyRIO and everything comes already pre-connected. But if you want to look at the wirings, if something's not working correctly, you can use this wiring diagram. So this is the list of operation procedure. The very first one you should probably do is as soon as you receive the MyRIO, go and install LabVIEW. You can find the software in this link because we have had problems in the past that teams had a lot of trouble going through the installation process. So if you have any problem, reach out to us. We'll get it sorted out. Then we have uploaded a video demonstrating how you can put everything together to get a testing done. Watch the video. Then another thing to keep in mind is the spindle lock. Whenever you remove or attach the spindle lock, make sure the air is always connected to the spindle. This is a blue rag that protects the ball from getting scratched up. Procedure to download NI MyRIO. So we recommend using 2019 and a Windows 10 computer. If any of this didn't go well as you planned, again, reach out to us as soon as possible. If your school has a license, this will not be a problem. If you don't have license, NI lets you evaluate for 7 days first, and then for 45 days. So if you can't figure this out, again, let us know. We'll get it sorted out. These are the deliverables. About 3 weeks from now, we'll have a preliminary presentation where you will report your progress, and the committee will give feedback on that. And we'll also release the measurement that we had made of your ball so that you can assess your performance by yourself. Because it's a preliminary presentation, you won't be graded on any quantitative measurements. You'll purely be graded on your progress towards the completion of the challenge. Then a few days before the conference, submit the two-page report of your findings and also the evaluated measurement uncertainties. At the challenge, all of you will measure a single common ball, and we'll let you know about the details of the data that you need to provide us and the time constraints and all that. This is a new thing we added this year. It's a post-competition rebuttal. You won't be necessarily graded on this, but it will be considered if there's a tiebreaker. If two teams performed really well and they had equal amount of points, we'll consider this post-competition rebuttal. Then the final presentation at the conference, we would need at least 2 students per team to present, and keep your presentations less than 5 minutes. So these are the resources, LabVIEW, and also LabVIEW software and literature, which could help you get it up and running, can be found in this Google Drive. We've uploaded Byron's tutorial he gave last week and the demonstration of the tool in this YouTube video. And this year we want to try out Slack. We tried Reddit last year. That didn't really work out well. So Slack is really here because when you ask a question, it'll be nice if everybody hears the question and one team would have already figured it out, can actually help you solve the issue. And yeah, here's our committee email as well. So this is the list of committee members who participated this year. We meet pretty much for about 45 minutes every week to get this all up and running. Yep, thanks to all of them. Questions?
It was either fabulously clear or totally confusing. Oh, which one?
Thank you, Kamal, for the presentation. I just have a small, like, simple question about the kit because I received the lion drop
Yeah.
within 3 weeks from the shipment. I'm not sure if the actual spindle and the other components will arrive as well in 3 weeks, or
Yeah.
maybe quick one.
Luis is working on that. Can you answer, Alim, Luis?
Yeah, for the particular one going to the UK, we had some issues at the school trying to ship them. They implemented a new measure that in order to ship anything international, you need to pretty much get approval from the university. So that is taking about 3 days now, and still haven't received the shipping ticket. And with the other teams, we're still working on putting together the kits. For example, this part over here, no, I don't have it with me here, but one of the parts, the holes were not aligned properly. So we had to drill them a little larger, and there were quite a few hiccups, including the LabVIEW, trying to get them to work with Windows 11, for example. And so that's kind of the reason I would blame we haven't been able to ship that. But at the end of the day, it's really manpower. We had a limited amount of time to do this work, which is a lot. The only plus for you guys is that you're going to get a spindle that is pretty much ready to go. This is going to be assembled. If you show that slide, Kumar, with the parts, I can explain what you're getting. The spindle is completely assembled, and the reason is because it was easier to ship that way.
Okay.
That's mainly the reason. And so traditionally, PI And that's the one. And the left is that's the spindle. So it's actually being shipped that way. I don't think you have a picture of the lock that I implemented, but I implemented a different lock. Uh, yeah, there it is. The lock goes all the way to the top, right? Rather than traditionally goes only between the rotor and the stator of the spindle. By implementing this over the whole assembly, allows you to shift everything in one piece, including the ball there with a little hat. I don't think Kumar elaborated on it, but the procedure to remove that spindle lock, uh, it is very, very important that you pressurize first before doing anything. And then you can remove that spindle lock on the upper left, on the, not upper left, but on top or left of the spindle, right? And save it somewhere because anytime you're going to kill the power of the spindle, oh, I'm sorry, the air to the spindle, you want to put that one back. No need to tie it up real tight because remember the threads are aluminum, so you have limited amount of life on that. And but by doing that, you can cut the air if you're not working on the spindle and save some desiccant. So that's about it. But they will be like that, ready to go. So that's the only
Yeah.
advantage.
They also,
Dialing the ball, it won't be perfect. That would be part of the challenge, right? And maybe for that, I like to point out that all these balls been measured as long as you don't scratch them, right? And putting a cap gauge that has a total travel of 50 micron could be challenging, right?
yeah, in the YouTube video we made, we explain these things clearly as well. And
Yep.
Byron had a question.
Well, your picture kind of answers it. I just wanted to make sure that there was a standoff underneath. See what
Yeah.
the window lock has on the right side. It has a standoff, and that's good. That's a good thing. So, and Luis already explained, you put the air on before you remove the lock, and then you leave the air on until after you put the lock back on if you want to, if when you're all done. So what he has in his notes, it's important. The order is important. So keep that in mind. Then the other thing I wanted to mention about when you dial the ball in, don't put the mechanical indicator right on the same track where you're going to use your capacitive sensor. So you would say, well, I want that part to be perfectly dialed in. Well, you can get pretty close if you just move up. Let's say the probe has a sensing area of 8 millimeters, I think, or no, 60 thousandths. And I think it grows about 30% when it gets to the ball. So just move up like a quarter or a couple hundred thousandths from the center track and dial that portion on or go down below. It's probably easier to go above, but you could go above or below. Just don't let your mechanical indicator touch where the capacitive sensor is going to be.
Don't put it on the equator.
Right.
Yeah.
Yeah, that was the easy way. I should have said that.
Yeah.
And it looks like your indicator tip is steel or carbide, maybe.
Steal it.
Okay, yeah. So also that will cause a scratch on the ball. So make sure that you're not on the equator, as Stuart helpfully
Yeah.
simplified my explanation.
Yeah, we explained it in the we showed that how it's done in the video too. And interestingly, what the dial indicator says did not match when I spin using when I measure using the capacitance probe. So it's either the off-axis forces on the indicator that gives a slight. It's still within tens of microns, but maybe the off-axis forces acting on the indicator is slightly different when you're at the equator compared to on the top, or it's just a not a great indicator. But yeah,
And also the convolution of the sensing area on the ball versus the contact tip on the ball.
Mhm.
So think of it as the difference between using a fine tip Sharpie and a king size Sharpie, if you know what I mean.
Mhm.
King size is big and the fine tip is small. So you get to see more of the surface finish when you use the fine tip.
A Sharpie is a felt pen for people in the UK.
Sorry.
Oh,
Okay. Here's a Sharpie.
first pen.
Yeah.
So this is your cap probe. Okay. Here's another Sharpie. This is one of my favorites. And then this is your, whoa, this is your mechanical indicator. So anyway, was there anything else? Oh, what I was going to tell you, you can also use the capacitive sensor to dial it in. Our guy that does these measurements, he's gotten so good that maybe you have a streaming, if you have access to like the
Yeah.
lab view, you can just look at the sine wave there and you can, and he even uses it on auto scale. So I think when you're first getting started, it's best to not use auto scaling. So just have it to the plus or minus 10 volts. And then once you get good at it, you can use the auto scale.
So yeah, I want to mention that we also uploaded the LabVIEW program that you want to get started with. It has its the calibration of the capacitance probe written in. That will change for every team. So you have to change those values before you start using the program that converts voltages to micrometers.
And one more thing about dialing it in, you don't have to dial it in perfectly, but it's a signal to noise issue. So the better that you can dial it in, the more likely you are to see stuff that's important.
Mm-hmm.
So, and keep in
Maybe
mind
maybe
your
it's a little bit kind of a trivia, but can we go over a little bit how you actually dial?
Yeah,
Like,
it's in the video. Everything is captured in the video.
okay, so we should have watched the video before coming to a meeting.
Yeah, it's the kick. This is the grand announcement.
Okay.
I, I feel like I didn't prepare for this test.
Yeah.
Mm-hmm.
One more thing, when you're using the capacitive sensor, you're going to pick up noise, dirt and fingerprints and stuff on the ball. So what we found is it's a tricky thing to clean the ball,
Mm-hmm.
especially when you're looking at it with a capacitive sensor. So you might have to develop a technique where you're cleaning the ball. What we do typically, we're running the spindle. It doesn't have to be very fast. And we might start with a nice clean rag with some isopropyl alcohol and just rub it right on the track where the cap probe is looking. And then if you still see funny stuff that shouldn't be there, like sharp scratches or whatever, it look like scratches, then use like a Q-tip. If you know what that is in the UK, that's you're
Cotton
not
bud.
supposed to stick it in your ear.
Cotton swab,
Cotton swab,
Cotton bud.
but yeah, earbud.
aka the thing you're not supposed to stick in your ear that everybody does. And put just a tiny bit of alcohol on it, or maybe don't do anything with the alcohol. Just do it dry because the alcohol leaves a residue. So
Yeah, I say the complete opposite in the video. I say if you put fingerprints, don't worry too much. Take Kim wipes and put some alcohol and wipe it away. That's what I said.
no, that's okay. But when you want a good measurement, you don't want the fingerprints there.
Sure. Dr. Smith, what's Kim wipes in UK?
I can't remember. It's been too long.
Yeah, maybe
I know
no,
we
no.
had them. Basically lint-free cloth,
Yeah,
optical cloth, uh,
Expensive Kleenex.
expensive Kleenex, expensive tissue paper.
yeah.
Uh,
Byron, do you guys worry about grounding your balls at all?
It, it is important to ground depending on your noise environment, electrical noise. And you'll see funny stuff in your asynchronous that will immediately lead you to want to try grounding. And my approach for grounding, I'm not as smart at electrical stuff as Stuart or any of you other guys. So what I just do is I go around and I try grounding different things. And if asynchronous gets better, then I stop. If
mhm,
it gets as good as I need it to be, I stop.
mhm.
Yeah, yeah, the setup we provided doesn't have any means of grounding, but we didn't observe it being any big of an issue. But yeah, students can come up with clever ways of grounding it.
It just
Well,
depends on what outlet you plug into.
Yeah.
the
Those
That's
cap
right.
sensors are touchy, man. If you
Yeah,
happen to be next to the transformer box in your building or something, it can
right. Couple.
weird stuff happens.
but
I
the
would
clip has
suspect,
a croc clip on it. Is that right? So
Yeah.
The
you
kit comes
usually
with a free clip. Yeah,
attach it to one of the screws if it's not got black oxide on the screw.
if it's
right.
gonna be spinning though.
No, no,
Yeah,
no,
you
the
you can
station
just
one.
like
Put it on the
get like
station one.
a wire
Oh,
or
I
something
see.
and like have it rub on it or something.
Yeah.
Yeah.
Yeah, I have a question. Maybe Byron can answer. In reality, you had to, or I think Kent was on the line too.
Oh, it's here.
That in reality, the target should be the rotating part, right? And
Mhm.
so the way this cap cages work, you really wanted the target to be grounded, but the target is actually rotating and is isolated from from the stator, right? Through an air gap. So
Yeah, but that air gap
what
gives
would be
you
the
a very
difference?
large capacitance, right?
Exactly.
Yeah.
So what would be the difference? Technically speaking, might be better just if you had like a little ring or something touching the aluminum that is rotating, and then you have a good way for the charge to go back to the amplifier because that's what you're doing.
I would not recommend that.
I mean, a very simple test would be to measure the noise, lock the spindle if you want with air in it, of course, and
No, if
measure
it's
it.
locked,
What?
you have are automatically grounded.
All
Yeah.
right, don't lock it and measure
No,
it.
you're on the right path, Kumar. What you want to do is the source of your noise is the motor. So what you want to do is disconnect your little O-ring or whatever it is, let the
Yeah.
motor run, and then free spin the spindle just by spin it with your hand so that you can data collect. And then turn off your motor and do the same thing and see what the difference is between those two tests.
Mhm.
And then you know what your noise floor is.
Yeah.
Mhm.
Yeah. Also, a static test. Don't move anything. Measure it and ground it and measure it and see if you see
Yeah.
any
And when you
discernible
do
difference.
that, when you do that test, you can also do the pressure dependent noise test that I discussed.
Yeah.
And something we've found that works on a rotating target like that is a little carbon fiber brush because
Mm.
they're conductive and it can, follow the rotation.
Yeah, or like a braided. You can just get like little braided ground straps and just like lightly touch it. It's sometimes
Yeah.
that helps. Sometimes it makes it worse. Sometimes it helps. It's very like it was said. It's very grounding. Uh, these types of things is trial and error.
Yeah.
Oh,
The Lions kit comes with a braided grounding cable too.
so this is the brush that we use. It's uh
Oh,
maybe I
yes.
can get like right here. Aegis makes it.
Uh-huh.
Okay. And this is set up. I mean, they don't use it for what we use it for, but it's set up so that you could put it right on some part of the ball, not the important parts of the ball, but some part of the ball or the target,
Not
or
the equator.
or even the rotor. Um, so these are expensive, but I'm willing to let somebody borrow one if they suspect that they have a noise issue and then this solves it. If it doesn't solve it, I take it out because it's just clutter. And when you take a picture of your setup, then you got to do a bunch of explaining.
Can you send us the link with where to get those?
You're not going to want to buy it. You'll want to borrow it from me. I'll send you one.
No, don't worry about it. I don't even have it set up. So, well,
All right.
right
Well,
now I have all of them.
how about if I send you the link just so you can see what it's about?
Okay. I'd love to. Yeah.
Right. Yeah, we've been talking. What about the students?
Yeah.
I
I
think
think
you'll get pretty good performance if you just uh, put the ground on the stator. I'll put my. I could be wrong.
No, I agree with that statement.
Yeah.
That's what we do 99.99999% of the time.
Yeah, no, for sure. It just every once in a while,
But you
you
have to
know,
have a pretty clean noise environment,
Right.
electrical
right.
noise.
Yeah. Remember, our motor has kind of got a Faraday cage, right? So the motor looks like that, and it's all the stuff is in a Faraday cage, and it's fairly small and it's fairly far away. So
Is it a brushed motor?
yeah, it's a brush
yeah,
motor, so that's also better than the brushless
yeah,
because you're commutating.
yeah.
It's a
Uh,
turntable motor.
I thought
It
I'm not
is.
a electrical guy, but I thought a brush motor creates sparks.
It's true.
Okay, the sparks are the problem.
Our A to Ds will probably filter that.
Okay, good luck.
Yeah,
It's also very far away where we're measuring, and it's
yeah,
powered independently through the USB port of the
yeah.
computer.
Well, this actually. Oh yeah, yeah, yeah.
Well, the
So
truth is, you should never worry about the noise problem until it's a problem. If it's not
Exactly.
a problem, you got lots of other stuff to worry about.
Yeah.
this is
Yeah,
something we could probably talk for 2 hours or more.
Yeah, yeah,
sure.
yeah.
Yeah. I'm gonna
It's
start
just a
asking.
frustrating problem, so I wanted to throw people a bone, but
Yeah.
So, Zihan, what do you expect from the student challenge? Zihan Chen?
Yeah, I expected that I can get some valuable measuring knowledge from the competition.
Gotcha. How about Farzana?
Yeah, it would be a completely new experience for me, so I'm hoping that I'll learn something new. I have never worked on this field.
Gotcha.
Mhm.
But I was going to
Sa-
say, Farzana, if you don't have anything to do, I need help putting those things together.
Oh, she's from Austin. Okay.
Yeah,
So, how about Danish?
Hi. Yeah, I've been listening to the presentation. Can you hear me?
Yes.
Yeah, it sounds pretty completely new to me. I'm here to get back to you once in a while to ask more doubts on it.
Yeah, please keep
Yeah,
asking questions. Post them in Slack, and we'll keep an eye on it. If it doesn't get
sure.
any
Once we get the
response,
shipment, it will
yeah,
be more easy to ask more.
right.
Yeah.
Yeah,
I think it's like riding a bicycle, right? You have to get on it to learn.
yeah.
Yeah.
And you have to fall a few times.
Yeah.
And
That's how we learn, right?
yeah. So, how about Dallin? Dallin Plummer, right? Yeah, there he is.
Hello.
Yeah, we can hear you. Yep.
Not now though.
Yeah. All right. How about Hassam? Hassam.
Right, hi. I'm here just to see if Alim need any support from us from
Mhm.
university. So it's quite interesting challenge. Looking forward to hear more what
Mhm.
the students can do. Thanks.
And Hossam and Simon, they are our supervisors in Huddersfield University.
Oh, gotcha. Yeah, thanks for attending. It's always fun to have a new team participating.
It's a topic that I'm very interested in, so I'm happy to support the team. It's great.
Mhm.
Awesome, thanks.
It's a great learning opportunity.
Yeah. About Nicholas, do do you know anything about spindles?
I might.
Yeah.
That's a diamond turning lathe.
Right.
So
Yeah.
yeah.
Yeah. Tobuchiku.
Yeah, I I have had some little experience um an aviary stage, and we were trying to use it for like um an AFSD thing. So I guess it's an opportunity for the one you guys are doing. I guess it'll be better when I look at it, but like I just wanted to ask like what is the you know what is the should I say maybe because I was late. Like, what is the impact in the machining field? Like the one you guys are sending.
Gotcha. So,
Like,
Louis, when do you expect the teams to receive the kits?
They will receive them when they receive them.
Mhm.
I'm hoping will be done maybe no later than Wednesday,
Okay, great.
and maybe let's say 3 days ground, and hopefully I can get an okay for shipping. The one for the UK is going to take the longest, about maybe a week.
Okay,
So if we ship that today, that would be great. So that we
gotcha.
can start on Monday.
Okay.
Now, like I said before, having them assemble is going to save you guys a lot of time. And could you maybe elaborate a little bit on the amount of timing that it's actually going to take
So,
this kind of
yeah,
work?
I would say lab view installation can take about an hour if everything goes well. And if you watch the video and start setting it up, you can get a measurement done in 3 hours total.
From setup to measurement, right?
Yeah. Yeah, tapping the ball in it takes some skill, but you'll get there real easy. Just you gotta go by the feel and tap it in and get the ball centered. And once you're there, once you do it once, the second time it gets easy.
I think it's probably worth pointing out. I don't know if you've done that in the video, but
Uh-huh.
when you're screwing screws down, you really don't need to put the wrench in with the long handle out there and pull hard on it, right? I mean, as tight as those screws need to go, you can probably just do that with finger and thumb on the short part of the hex key. Does that make sense?
Yeah, and luckily we didn't give them 90-degree hex keys. They're all screwdriver type. You
Okay,
can only
yeah.
put so much torque.
You really don't want to look at it as a exercise, right?
Yeah,
You
yeah,
just try to imagine. Actually, with a screwdriver, if you just grab the screwdriver with thumb and finger, that's
yeah.
about
So,
as tight as
yeah,
you need
for
in
let's say
things.
go back to that slide, Kumar,
Yeah.
for
Which slide?
reference,
This slide?
the one with the spindle, that one.
Yeah.
For reference, there's two bolts on the top next to the ball. Those have a dowel pin, so it won't help you to try to loosen those up to align the ball. So I will just use the three outside. Uh, those are the ones that you need to loosen up in order to push laterally the ball to align it, right?
Yeah.
Those, because of I was going to ship it, and they're pretty much holding the whole assembly together. They're torque to 12 pound inch. Excuse me for the metric, guys. I don't know what that is uh, in the metric system, but anyway, the only reason is 12 pound inch is because that's what my torque range is capable of measuring. In
That's the
reality,
smallest torque, right?
32 should be more like 19 pound inch, right? But there's also aluminum involved in here, so I didn't want to go too far, right? But that
Yeah,
should be
again,
good enough so it won't move, but you won't be able to dial it at 12 pound inch. You're going to have to, like Stuart said, loosen those up and then maybe use your thumbs to get them up to where you can dial it in, right?
yeah, again, make sure when you tighten the bolts, the spindle is pressurized. The air should, it'll start rotating when you kind of tighten it. Yeah, you want that rotation when you're tightening it, so the rotor is free from the stator. Yeah,
Yeah.
all this is shown in the video too.
Okay, good.
And we had a question about the deliverables. Yeah, so the first thing you need to look for is, no, this is the tentative date, but it's probably going to be around that time frame, 3 weeks from now. Yeah, Kevin, do you have any questions on the timelines? It's not you see it right away here.
Yeah, okay. Thank you so much for the presentation. And yeah, so we are just expecting the kit to arrive, and then yeah, that's what like I asked, what's the timeline, and yeah, what's the deliverables. Yeah, thank you so much.
Yeah, you're welcome. So yeah, this year we kind of dialed down the amount of time that students have to spend. If you notice, the previous year's challenges involves a lot more controls and mechanics focus. This year's just purely metrology, and it's as easy as it can get to get a measurement done. And once you get your first measurement, then you can start improve on things. All right. Yeah. Any more questions or comments?
I would say, start early on trying to install the MyRio and LabVIEW, MyRio drivers and LabVIEW. People have issues with it just because they're not familiar with how to negotiate through National Instruments websites. So give it a go, and if you hit any problems, don't struggle. Quite
Yeah,
often
just
you hear
ask.
people, a month after we've delivered, say, well, they can't get something running. Don't do that. If you can't get it done within a day, then you really need to call.
We are happy to jump on a call anytime.
So maybe we can finish the meeting earlier.
Yep. Yep. 8 minutes.
We're all busy folks.
Yeah. Yeah. Thanks a lot to the students and the sponsors and the advisors that attended the meeting. We'll make sure we share the PowerPoint, and the video will be uploaded on YouTube. So
See
Nilab
the
had
chat from Nilab.
yeah, Nilab says since it's a metrology challenge, focus on minimizing different sources of error, or come up with test plans, analysis methods to minimize or accurately quantify different sources of error. Yeah, he's talking about error budget or uncertainty evaluation. Yeah, that has a reasonable amount of points to score.
Yeah, I would say there's a lot of emphasis on your evaluation of the process.
Yeah.
And so it's not on who gets the best result, although that certainly makes a difference. But there's a good chunk of recognition of your evaluation of the errors and error sources in your process.
And the tentative rubrics is also available in the Google Drive.
You had the link for it?
Yeah, it's all in the PowerPoint.
Okay, good. Because I was supposed to put it up on. I'm the webmaster too, so I was supposed to put it on the web, but it's not there yet.
Yeah. I'll take care of that.
Okay, good.
All right. Yep. Thanks, everyone. Have a
Yeah,
good
thanks,
rest of
y'all. Appreciate attending.